Okay, geometry students, this is Mrs. Raposa. I'm going to just briefly go over some of the problems that were in the homework that was due on May 6th, right here, this homework assignment. So just before I do that, I just want to briefly discuss with you sine, cosine, and tangent ratios. It just relates opposite leg to hypotenuse. For instance, if your angle measure theta is over theta, use a Greek symbol. It just stands for an unknown angle measure. In reference to this angle, we have an opposite leg, an adjacent leg, and a hypotenuse. In reference to this angle down here, this side is opposite that angle, and this side is adjacent or next to that angle. And the hypotenuse is always the hypotenuse. It's never the adjacent leg, and opposite legs are definitely legs. If you're talking about the angle up here, then this side is the opposite leg. This is the adjacent leg, but the hypotenuse is still the hypotenuse. So sine is the opposite leg length over the length of the hypotenuse. We call it O over H. The cosine ratio is relates the adjacent leg length to the length of the hypotenuse, A over H. Tangent ratio relates the length of the opposite leg to the adjacent leg. So the hypotenuse is not part of the tangent ratio. So let's use those to go through these problems. So for number one, you had to find the sine of angle x and the sine of angle y. Well, in relationship to this angle x here, the hypotenuse is across from the right angle, that's 17. And the opposite side here is 8. And the adjacent leg is 15. So sine is opposite over hypotenuse. So opposite over hypotenuse would be 8 over 17. The sine ratio for angle y, opposite angle y, is the 15 length leg. So that's going to be opposite over hypotenuse, or 15 over 17. Likewise for this one, sine of angle x is opposite over hypotenuse, so 15 over 25, which reduces to 3/5. And the sine of angle x is going to be, sine of angle y is going to be opposite over hypotenuse, so 20 over 25, which reduces to 4/5. And there was a little bit of a typo. I'm sure that meant cosine r and cosine s. So the cosine of angle r, opposite angle r, is, cosine is adjacent over hypotenuse. So we need the length of the adjacent leg, the leg that's adjacent to angle r. That's going to be 9 over 15, adjacent over hypotenuse. So 9/15, which reduces to 3/5. And in relation to angle S, the adjacent leg is 12, but the hypotenuse is still 15. So 12 over 15, so the cosine of angle S. 12/15 reduces to 4/5. And I think you can kind of figure out what's going over here with cosine R and S also. Just remember, in relation to R, this is opposite, this is adjacent. In relation to angle S, this is opposite leg, and this is adjacent leg. So they switch depending on which angle measure you're talking about. Okay, so for these problems, let me see if I can pull this up just a little bit so you can see what's going on. So you had to find the length x. Well, in this problem, we have the 39-degree angle down here. That means that this is the adjacent leg, and this is the hypotenuse. What ratio relates adjacent leg to hypotenuse? Adjacent over hypotenuse, yeah, that is the cosine ratio. So we're going to use the cosine ratio in this case. So the cosine of 39 degrees is adjacent over hypotenuse, or x over 26. So that's how I set it up. Cosine of 39 degrees is leg length x over the hypotenuse length 26. And just multiply each side by 26. 26 times the cosine of 39 degrees. Cosine of 39 degrees is about 0.7715, as long as your calculator is in degree mode. Make sure it's in degree mode. And you'll get about 20.2. For number 6, you were, in relation to the 61-degree angle, you were given the length of the hypotenuse and the length of the opposite leg. So opposite over hypotenuse, which ratio is that? That's the sine ratio. So I'm going to use the sine of that angle measure. So the sine of 61 degrees is x over 17, and that's how I set it up. Multiply each side by 17, so x will be 17 times the sine of 61 degrees, which comes to about 14.9. And the very last problem, you were given, in relationship to this tiny little 16-degree angle, the opposite leg length is x, and the hypotenuse is 18. We don't even care about this one right here. But what ratio relates the opposite length to the hypotenuse again, that is the sine ratio. So we're going to use the sine of 16 degrees is opposite over hypotenuse. Sine of 16 degrees is x over 18. Multiply each side by 18. So x will equal 18 times the sine of 16 degrees, which is about 0.2756. Multiply that by 18, you get about 5 or 4.96. Hopefully that helped with the homework.